To support the investigations on the ground, an operational BOAC Comet, Able Victor, was subjected to an extensive series of flight tests. Never before has an aircraft been so extensively equipped. The passenger cabin was stripped of unnecessary furnishings and fitted with recording instruments. Electrical resistance strain gauges recorded in flight the dynamic and steady loads at 60 measuring points in the aircraft. The crew were briefed before each flight. The pilots were RAF officers of our experimental flying department, and the observers were civilian officers belonging to our scientific staff. De Havilland flying personnel also took part in many of the flights. All civil aircraft are subjected to prolonged proving trials before they are introduced into service. We were looking for things outside the normal range of such tests. As the work on the ground went on, extra items were added to the flight test program to confirm the results of laboratory investigations. As a safety precaution, the aircraft was flown unpressurized, the crew and observers being provided with special parachutes and using oxygen above 10,000 feet. Strain gauges at the tailplane roots and at some of the outboard positions could be combined in various ways. For instance, port and starboard gauge signals could be added to give a measure of the symmetric tailplane load. Alternatively, the signals could be read separately when asymmetric loads were required. The aircrew and observers spent many tiring hours concentrating on their instruments. No chance of a smoke, but a peppermint helps. The maximum airspeed called for in the tests were 300 knots EAS and 0.8 Mach number, but these limits were not tested until late in the program. For the earlier flights, limits of 275 knots EAS and 0.7 Mach number were imposed. Structural vibrations were recorded and measurements concerned with the flying characteristics of the aircraft were made, together with the temperature of the engines and the cabin heating system. Throughout all the flight tests, another aircraft acted as a shepherd and followed Able Victor from takeoff to touchdown. Flight tests eventually culminated in a program of maneuvers and flights in turbulent air to check aircraft and pilot response. During these tests, Able Victor flew 70 sorties, totaling over 100 flying hours and a distance equivalent to a journey twice around the world.
We now return to the tank test, where the cycle of test was repeated continuously, apart from periods set aside for inspection, until a failure of the pressure cabin wall occurred. This happened when the equivalent total life of Yoke Uncle was about 2.5 times that of the Elba Comet. A small fatigue crack in the skin of a rivet near an escape hatch is considered to be the start of the failure, which developed rapidly. The damage was then repaired, and also a crack believed to be the beginning of another major failure. The tests then continued. When the equivalent total life was about 4.5 times that of the Elba Comet, a further failure occurred, a crack near a window developing rapidly, and the port side of the cabin was ripped open for a length of about 15 feet. This third failure confirmed that the structure around escape hatches and windows was vulnerable from the fatigue aspect. A series of laboratory tests were made to study fatigue stresses around a rivet hole, and specimens of aluminium alloy sheet, similar to those used in the Comet fuselage, were stressed in a fatigue testing machine 2,000 times per minute from 0 to 40,000 pounds per square inch. Under these stressing conditions, the specimen fractures in about 6 minutes. The examination of the Elba wreckage, which had proceeded simultaneously with the fatigue tests, indicated that failure started at a direction-finding aerial window in the roof of the cabin. There were 2 of these windows, and the failures originated from the rear one. On one side of the rear window, the failures run forward from a corner and pass through the front window. On the other side of the window, the failures run aft, so splitting the fuselage along the top centre line. Under the action of the internal pressure, the 2 halves opened outwards, broke away, and were projected violently along the wings. There is a strong similarity between the failures in the wreckage and in the fatigue tank. When seen side by side, these failures provide a most striking demonstration of circumstantial evidence. All the structure in the region of the ADF aerial windows was microscopically examined, and strength test specimens were taken from the material. In one corner of the rear window, signs of fatigue were found. This direct evidence of fatigue, and the close similarity with the failures in the pressure cabin fatigue test, gives convincing evidence that the disruption of the pressure cabin was brought about by fatigue.